Hello, I'm Pittsburgh Pat. Welcome to the podcast. And I've got Eric Fischer here. Eric, how are you today?
Doing very well, Pat. This is as I mentioned to you earlier, this is my first time doing an interview on YouTube, so it'll be interesting.
This is great. I love it. I love it. I've been doing interviews now for 3 years and on YouTube, and I'm having a great time with it. And I always have interesting people. And I asked you because I know you're interesting. We met at the Allegheny Observatory, and I was introduced to you by another person who's been on this podcast, Diane Turnshek. So we have that wonderful, amazing person in common. And so she introduced you to me because I was thinking about going to the Moonshot Museum and touring Astrobotic, and you're a volunteer there, and you basically gave me a private tour, which was amazing. So can you tell me a little bit about how you got involved in that and what that's like for you?
Okay. Well, like a lot of kids when I was very young, what were kids interested in? Planes, trains, and automobiles, right? Battleships, whatever. And then the Mercury, Gemini, and Apollo program started to kick on in the mid 60s, and this just started to become interesting and was something different, not the same old stuff, planes, trains, and battleships. And then my dad took me to the launch of Apollo 11. We drove 2.5 days to Florida.
Wow.
Before there was an interstate. And we were about 6 miles away from the launch pad on the north side of Merritt Island. And it was a mind-bending experience. For anybody who wants to know what a rocket launch is like, just go to a fireworks show and wait till the grand finale. And you feel the concussions off your body during the grand finale. That's basically what a rocket launch is like. But this was the Saturn V moon rocket, 36 stories tall, 180 million horsepower. It was stunning. And of course, for a lot of people, it was a cathartic event. Wow, now I'm interested. And that was the launching point for my interest. And ever since then, I've learned something about people, looking at myself and talking to other people, that when you get interested in a subject, whatever it may be, astronomy, space exploration, archery, plays, when you hear something, you latch on to it right away in your mind. You don't lose it, you don't forget it. And that's same with me. Anything about the space exploration business, I hear it and it goes in and it gets in that permanent storage that I can get to. So
I had a college roommate who was really into Apollo. So it was the kind of thing where I either got into Apollo or, we weren't going to have, it was going to be a thing. So I learned so much about Apollo in college. I was very interested in it in high school, but that was really what solidified it for me. But I've never met anybody that was at the launch of Apollo 11. That is amazing to me. Now, that island that you mentioned is kind of famous, right? Because I remember, you look across an inlet of water, right, in order to see the launch site. Mm-hmm. But you said that if I go down for a launch, there's a better place.
Yes. For any of your subscribers, if you want to go to a rocket launch, go to the Kennedy Space Center Visitor Center outside parking lot. It's only 5 miles from all the pads. If you go to any of the beaches or coastline observation points for a rocket launch, you're more like 8 to 10 miles away. The Visitor Center parking lot is only 8 miles away. It's $10 to get in. The tree line is very low there. There's restrooms nearby if you want to go into the visitor center, get some food. But that's where I went for the Artemis 1 launch. And that's what I recommend. If anybody wants to do this, Kennedy Space Center Visitor Center, the outside parking lot. It's an excellent location.
Well, that's great. Now you have a vast interest in kind of background with astronomy, your relationship with astronomy. You're also, what is your position with the amateur astronomers of Pittsburgh?
Right now, I'm the editor of the newsletter, and I'm on the staff of Wagman Observatory. Over the years, I've been president 3 times and membership secretary once. You jump around, but I prefer a job like the newsletter editor because you don't deal with people's personal conflicts. When you're the president, everybody comes for you for the solutions, and that wasn't for me. But
yeah. Well, what's your at Wagman? You guys, that's an observatory that's relatively a good distance away from the city lights. So you guys can see some amazing stars when it's not cloudy.
Right.
So,
Yes, Wagman Observatory is in the northeast corner of Allegheny County. When we built the first wing of the observatory in 1986, we dedicated in 1986. And at that time, the southern sky, facing Monroeville, Pittsburgh, was not bad. A little bit of light pollution, but we had a pretty good view in that direction. And of course, the other directions, west, east, and north, very dark skies. But that was how many years ago would that be? 30 years ago, 40 years ago.
yeah.
Now the light pollution has really grown as the suburban population has grown.
Oh,
So
sure. I mean, the north suburbs have exploded with the building of 279. So there's a lot. It's easier for people to get to work if they work in and around the city.
Right. Well, we had to make a compromise. We could have located the observatory way out in the Pennsylvania countryside, but fewer people could get to it.
Yes.
So it's not in the city, but it's not in the ideally where you would put it in the country. And because of all the southern light pollution, then we decided to build a second observatory, Mingo Creek Park Observatory in Washington County, where now we have light pollution to the north and dark skies to the south. So we've got our north and south skies well covered.
That's great. So when did Mingo open?
Mingo was dedicated in 2005.
Oh.
The building is similar in structure to Wagman. We have one large refractor, one large reflector, but Mingo also has a planetarium.
Okay.
And what that does for us, if it's a cloudy night, we still invite people to come there and watch the planetarium shows, look at the displays. When it's a cloudy night at Wagman, we just button up for the night.
Sure. I mean, that's the thing. So when I met you, I was at the Allegheny Observatory, which is really close to the city. It's just barely 2 miles from probably the center of the city, or maybe 2.5. And so there's a lot of light pollution. But in addition to that, there's kind of like, the weather in Pittsburgh, we get a lot of cloudy days. So, but what happens at the observatory is, for anybody who's not been there, I highly recommend it. It's free to go to the lecture. You have to make a reservation because there's a limited number of seats.
Right.
It's free. And you can also go on tours in the summer months that are free on Thursday nights. But the third Friday of the month, you can go and listen to a lecture that's given usually by somebody who has a degree in astronomy, or several sometimes. And it's usually on something very interesting related to astronomy, either observational, cosmology, or something like that. And it's a technical lecture that's designed for people who may not be well-versed in math. So there are few equations, if any, and it's designed to be an hour long. And afterwards, you can go up and look through the optical telescope, one of the optical telescopes. And, that's the first time I saw, Saturn through a telescope. And we just saw Venus, this last one, because there was a lot of haze from the Canadian forest fires. So there wasn't a lot of opportunity to see any like deep celestial objects. Right. But I've seen galaxies there, spiral galaxies, double stars that aren't apparent to the naked eye. It's a good telescope.
Yeah. It's a 13-inch Fitz-Clark refractor. It's meant strictly for public viewing. The optics are optimized for eyesight viewing. The other telescopes are more, think of them as very large cameras. So the light that you see is not as the right for your eyes. It's right for a photographic setting. What I'd suggest, Pat, is you and your subscribers come to Mingo or Wagman Observatory, where you can look through some fairly large telescopes, but the sky is much darker than Alleghany's.
That makes a big difference.
So,
yeah, you'll actually see the Milky Way down there.
Oh yeah. And Wagman, we have an 11-inch Brashear refractor, which is, for all intents and purposes, is about the same power and resolving power as the 13-inch at Allegheny Observatory.
I have to ask you, I know that for myself, I've seen people who witnessed the Milky Way for the very first time. And I remember when I saw it for the very first time. I was born and raised in the city, or the city environs. So it was, I was in my, beginning of my third decade of life before I saw the Milky Way, but it was an experience. Can you relate any stories about that, or maybe other observations from city folk who don't normally look through telescopes, and how how life-changing that can be, what an epiphany that can be?
Two things to tell you about that. First of all, if you've not seen the Milky Way, you really need to go out into the countryside. I'm talking even further than Wagman or Mingo. Mingo is okay. And the first thing you're going to say on a really clear night is, oh, geez, here's some clouds coming in. I thought we'd have a clear night. Then you realize that those clouds are actually the bands of the Milky Way. And the other thing that's interesting about that, or more than interesting, is that those bands are actually the collective light of millions or billions of stars. And I'll add a third addendum to that. Everything in the sky is Milky Way, not just that band of light. In fact, we are Milky Way. So it's the term given to the band of light that you see in the summer, but it's just, think of it as all that light is just millions upon more stars than you can imagine.
Yeah, I think the other thing that's sort of, for me, having sort of immersed myself in astronomy and some of the so I haven't done as much observation obviously as you, but I've heard a lot of lectures and I've studied a little bit, and I can almost, when I look at the Milky Way, I can almost feel like where I am in the structure, sort of. You know what I mean? Yeah. Like you said, the bands, it's like I can almost see the spiral arms and I can see where the center of the galaxy is. And that ability to positionally know where I am inside the galaxy is a really, it's hard to describe what that means to me. It's a at once I feel, the immensity of the universe I live in, or at least the galaxy I live in. I don't know that my brain has been able to kind of resolve the numbers that are involved with the size of the universe. But if I can approach the size of the galaxy, or at least where the Milky Way and where the Earth is positioned in the Milky Way, but also like a kind of like sense of uniqueness, almost of, how precious it is that the Earth is where it is, and the fact that there's life here, intelligent life that can perceive itself and perceive its space in the universe, but also, I guess, the moment in time that we're here. You know what I mean? Like, technologically, to be able to use instruments to observe. And one of the other things about astronomy that's always fascinated me, and I've asked other guests about this, but you would probably have, I think, a unique insight in this. When people ask me why I'm so fascinated, I tell them this: if I can only tell them one thing, the moon and the sun and the Earth and the relationship between where they are positionally, such that when the Earth is between, or when the moon is between the Earth and the sun, the moon is, apparently the same size. And so every once in a while, it lines up perfectly so that we're in the shadow and we can see, it just almost perfectly occult the sun, occlude the sun. And there's absolutely no scientific reason that has to happen at this point in time. Right. In fact, the moon is moving away from the Earth. Right. After the theoretical, the best theory we have so far is that a Mars-sized object hit the Earth at a glancing blow. And as a result of that, the inertia, the impact, the Earth is still moving away from that impact. That's the best we've been able to come up with so far. That's the current theory, right? Maybe there's a theory I don't know about, but
that's the prevailing theory, that a Mars-sized object crashed into the moon, glancing blow.
Yeah.
Took off a piece of the moon, which became the moon. And the question is, whatever happened to that Mars-sized object? Is it still out there somewhere?
Right. Is it some dark mass that may come visit us again? Well, there's all kinds of interesting theories about, nemesis and other things that maybe disturb comets once in a while, and why there are periodic comets. And, but you're into like supercomputer mathematical calculations that I don't really understand. But, there's a lot of interesting astronomical observational phenomenon now. I actually just did a podcast with a friend of mine where we both read about the Fermi Paradox. And we focused on the more scientific explanations. So we didn't get into like some of the more science fiction kind of theories, I'll put it that way. But we got more into the hard science theories. And there are objects that we believe now that are extra solar system. There's an object that has a really strange shape that's kind of hurtling through the solar system right now that we've detected. And I'm going to butcher their name if I try to say it, but it starts with an O.
Oumuamua.
Thank you.
And I think it's Tahitian or Pacific Islander, but it's Oumuamua.
Is there?
It was the first asteroid on a interstellar course. Instead of orbiting the sun permanently, it came in from interstellar space and is on its way out. Yes.
And that's how we think it's extrasolar, is it doesn't have an orbit that would be like almost Kepler, according to Kepler's laws, right?
Yeah.
So that's probably the first one.
It reminds me of the Clarke novel called Rendezvous with Rama, Arthur C. Clarke's Rendezvous with Rama, where an object came in from interstellar space, and of course it was in the story it was an alien spacecraft.
Sure, and that's the thing. I mean, the thing that we were talking about in the Fermi Paradox is that at some point, there might be a situation where we will have made contact with an alien civilization without even knowing it for years,
right? Maybe
decades, maybe hundreds of years, because we just don't recognize it as technology, or we're just not smart enough yet.
Well, there was a really good book years ago, and I can't remember the name of the astronomer, and he was talking about life in the universe, and the title of the book, Where is Everybody?
Yes.
We're looking
at the one we read, I think. That's the one we read.
Yeah. You'd think you'd see some signs of like maybe an alien civilization took a bunch of stars and put them in a straight line or a square, something obviously artificial, because alien civilizations have been around a lot longer than we have. One astronomer named Freeman Dyson said, wait a minute, I've got an idea. These what are called red giant stars. Maybe those are artifacts that the aliens built a structure around a star to collect all of its energy, and a great place to live, and you have guaranteed energy. He was trying to explain these very gassy stars like Antares and Betelgeuse and some of the very large stars. So he was trying to find some visual evidence of alien civilizations.
And the idea that the Dyson sphere idea is a really interesting one, because now they've talked about Dyson swarms and they've like expanded the theory. But for a while there were people looking at a star that they called Tabitha's star, and it had some really odd like luminosity variations. Mm-hmm. And they were thinking, well, what are we looking at here? Is it possible that maybe this is what a Dyson sphere under construction would look like, or a Dyson swarm, or that sort of thing? Now, of course, using Occam's razor, like it's much more likely that it's some type of cometary cloud that's irregular, right, or some type of gas or something like that. But we don't. I don't even know if it's been conclusively determined what type of natural phenomenon is causing that. Maybe it has, and I haven't paid attention enough to the
last I read about it, there was no conclusions drawn, because several people had different theories.
Yeah, I mean, more data is needed, I'm sure, but it's interesting. And what I think about that is that there's room for lots of different theories, and there's a lot of inspiration for science fiction stories too.
Oh, yeah.
I mean, there's that Star Trek episode where I think it was it was Star Trek Next Generation, where Scotty comes back and they find a Dyson sphere, right? And actually, so a lot of these scientific theories have made their way into science fiction and vice versa. So there's a lot. What I love is the interplay between the two. So it's important to distinguish between the two, but it's neat to see that, like, I mean, for instance, you were talking about the 60s. Star Trek was the only thing like it on television, right?
Right. I saw the first episode in September. I still remember seeing the first episode in September of 1966. And right away I said, this is different.
Exactly. It was, I remember Roddenberry seeing an interview with Roddenberry where he said he had to sell it as Gunsmoke in Outer Space, or
Right.
no, Wagon Train.
Wagon Train to the
in Outer
Stars.
Space.
Yes.
Yeah, because you said
Yeah.
it was going to be episodic, and it was going to have a moral, and and it was going to be family entertainment, and but it took some really interesting leaps of.
Oh yeah.
I think it introduced and inspired a lot of people who later became scientists. They often talk about that, how they go back to that and say, I just didn't even think that was like a possibility until I read, until I watched that. And then I thought, oh yeah, maybe I can do science. A lot of these outreach programs, a lot of the things that you do with the amateur astronomers, that's got to be, there have to be people that you've inspired, through that. I know for me, first time seeing the rings of Saturn on, in the right angle, and actually like looking through a telescope and seeing the Cassini division and saying to myself, wow, what would, someone in the 1600s who just like pointed this in this direction, how crazy would that be? You see something orbiting another heavenly body, and then the concept of a heliocentric solar system becomes solid. It becomes, it's not everything revolves around the Earth. It just becomes so real. I've talked to a gentleman that I interview. He's got a book on cosmology, and I've been interviewing him for his podcast. And we talk about the fact that it's only been 100 to 125 years since we've expanded our idea of the universe as being larger than the Milky Way galaxy.
Yeah. Not a long time ago, but at the beginning of the last century, I have to be careful which century I'm talking. The other galaxies were regarded as nebula. The other fuzzy patches and galaxies were regarded as nebula within the Milky Way. And they didn't conceive of a much larger universe. So, but getting back to the universe itself, about where is everybody? The universe not only doesn't have a really bona fide visual examples of intelligence, but audible. It's dead quiet out there. There's natural radio noise, to be sure, but we're not overhearing traffic communications between planets, and that doesn't have to necessarily be radio communications. It could be lasers. It could be microwaves. It may turn out that radio waves are a primitive communications medium that other civilizations have long since discarded. So the quietness as far as artificial signals is very puzzling.
Yeah, and it's not only that. It's when we think about these ideas, we have to learn how not to be human centric. Just because we can use radio to communicate, why would an alien civilization particularly pick that? And there are other people that even said that gravity waves might be a way that civilizations other than ours would communicate. And we've only just detected those within the last 15 years. I think LIGO was maybe
less than that. I think LIGO was about 10 years ago or 8 years ago.
Yeah, I'm pretty sure. So that's the thing. As our we just launched James Webb. So as the instruments become more sophisticated, there's greater chance that if there is something out there, we might detect it. But as you said, the prevailing theory about the moon's existence is that it was a glancing blow by a Mars-sized object. Now, if that impact is at a different trajectory, the Earth is pretty much shattered, right?
Yeah.
And you don't, and even if it coalesces again, you don't end up with necessarily a satellite that's 1/6 the size of its, so it's really not just the Earth. We're really an Earth-Moon system. We're really a twin planet system in a sense.
A double planet is sometimes called by some people.
Yeah, it's Pluto and Charon, like very similar to that kind of thing, except they're even more close in proportion, I believe. I think it's 1/4. Maybe I'm wrong about that. But the idea, there's so many things the moon does for us to stabilize the possibilities and make it very more pleasant to live here on Earth. The stability of the seasons, the axial tilt, the fact that it shields us from so many impacts, so many things. And I understand the universe is huge, But even on an astronomical scale, the chances of that happening, in addition to so many other factors, might be so rare that maybe life exists on other planets, but it's just few and far between, right?
Right.
Maybe we're just not at the right time. So at this moment in the Milky Way galaxy, when Enrico Fermi said, well, if it's common, they should be there. We should see them. They should be here. We should be able to look and see them, and we don't. Maybe it's not as common as we think,
But in a galaxy of 250 billion stars and a universe of 250 billion galaxies, let's say, there's something called, what was that formula? The Drake equation, about the Drake equation. But if you take the Drake equation and put it against the estimated number of stars and planets in the universe, that still comes out with 1 million civilizations in the universe. But then a lot of them are so far away that any kind of communication or transport is out of the question.
Or futile.
So we have to hope for something within 100 light years of Earth, and like you say, maybe the statistical odds are pretty low under the circumstances. So
there's so many things. I've been reading about it more because in the last few months after I read that book, it's really I've become fascinated with it. And by coincidence, the last name of the author is Webb as well. He's Stephen Webb instead of James Webb. But if that's the book that we read, and it was, where is everybody? But there's this problem called the phosphorus problem, which is interesting. So I guess phosphorus, I'm not a biologist, but I know enough to know about the ADP-ATP cycle, in which phosphorus is a way for animals to transfer energy. And so that's essential to life. Apparently, the distribution of phosphorus from supernovae in the galaxy or in the universe, it's patchy at best. And there are many places where it's poor. It's so poor that it wouldn't be enough to sustain the kind of life that we know. Again, a human-centric view, but it's the only life that we know. So if we think that, there are certain rules to chemistry and physics that we feel like life, the essential building blocks of the universe, being the elements, there have to be certain elements in order to have life. Phosphorus might be the problem. So, there's so many interesting things. And, the other part is, do we really want to be close? Do we want a civilization that's really close by? Do we want somebody that can come and visit us? Because if they are more advanced, we see what advanced civilizations have done to less advanced civilizations on our own planet. It might not be the best situation. It's like Hawking said, maybe we should keep our heads low and, not make ourselves conspicuous.
Problem is, if you look at the opening scene of the movie Contact with Jodie Foster, we started sending radio signals in the late 30s, and there's a sphere of radio and television signals expanding out from the Earth. So it's too late. We've told the universe we're here.
We're noisy. We're one noisy planet.
There's another, if you ever read any, I'm not well read on cosmology books that much. I don't have a mathematical mind, but there's something called the anthropic principle. Have you heard of that?
I have.
That we wouldn't be here if none of these factors lined up so nicely for us to be here. We wouldn't be here, and we just happen to be the ones that had all those factors come together to form life.
The strong nuclear force is often cited. There may be a universe which doesn't have atoms. There may be a universe in which there are atoms, but there are no stars. There may be a universe where, it's and the tolerances there's usually 5 big ones that are cited. The tolerances are very thin. So that makes it really interesting. So as a result, people have come up with ideas that there are these multiverses, that we're in a multiverse and we're just in one of the universes that's possible. But all these other universes exist where all the other permutations of these values are different.
Well, the laws of physics, the theory is that some of these other universes, the laws of physics are slightly different. And exactly. This allows a life, or it creates for another form of life. So,
and our assumption is that the laws of physics are the same everywhere in the universe, and that the Copernican principle, which is that there's nothing particularly special about any particular place in the universe since the laws of physics are the same. Black holes are starting to like tread on that a little bit, some theories of black holes, but you know, it's I think it's interesting because we're using science, but it gets kind of philosophical in a sense too. It's like, well, why did it happen here? You know, and I don't have a good explanation.
No, nobody does. The finest minds. I'll tell you, the one that intrigues me the most right now, and again, I haven't done a lot of reading on it, is the idea that we are living in a simulation.
Yeah, I need to read more about that. So what have you read about that?
Again, these are some pretty hefty texts I'm reading, trying to understand, but the scientists worked the problem backward. They said, well, wow, if you can create the universe from a nugget of space-time smaller than an atom, design the universe, and then it expands into what we have today. Couldn't some advanced civilization in their lab create a universe in a lab that's the microscopic size, and then they let it go and it blows up and becomes a universe? And
An interesting thought.
The theory is that we are living in a simulation, and they decided in that simulation that there'll be no other planets, no other intelligent life forms. We're the only ones, you know. Again,
well, it would explain the anthropic principle, because if you're trying to make a universe that gives rise to an intelligent civilization, then you have to make the numbers in such a way. But then there is another kind of part of that, and I don't know how much it has to do with the basic equations of the anthropic principle, but it has to do with the idea of like super Earths. The fact that if you're going to make a simulation, why wouldn't you make the civilization or the planet orbit a star like an orange dwarf as opposed to a yellow dwarf? Right. Because yellow dwarfs their lifetimes are shorter than orange dwarfs, and and even the size of the Earth is not as optimal as it could be for the giving rise to life. There's you could go into other things like photosynthesis. Why are plants green and not purple? Because purple would be more advantageous to plant life because it would absorb more radiation. All kinds of interesting stuff. So there's a counter argument to the simulation. That I like the idea of the simulation because any science fiction buff worth their salt has seen The Matrix, right? So it's a wonderful universe. It's a wonderful sci-fi property. I love it, and it's fun to play with. But so that kind of idea is really attractive in some ways, but the counter argument's pretty profound too. Yeah. So the
simulation theory provokes another question.
Yeah.
Who is conducting the simulation, and where do they live? Do they live in another universe? Maybe they live in one of these parallel universes. You're getting into very cutting edge thought process, or way beyond my knowledge.
Well, I mean, these types of experiments, and this is where I get back to with my friend who has the cosmology theory, is that, these types of thought experiments are exactly the type of things that theoretical physicists do. Einstein did. He talked about his thought experiments. But the thing is, it's not science until it's testable.
Right.
And repeatable, right?
Repeatable and testable, yes.
And peer reviewed. So, there are a lot of ideas out there that have been tested once or detected once. For instance, like the wow signal. That was what I'm talking about.
No, that one I'm not familiar with.
So the wow signal is Ohio State University had a detector. They had a radio telescope. And it was kind of small. It was in the back. It was like on campus, like near the football field, and it was kind of rectangular in shape. Anyway, in the 1960s, it detected a signal, a very strong signal, this type of signal that you would expect if someone were sending a signal to us.
Oh, yes. Now I know the one you're talking about. Yes.
And other people have said, well, there weren't any like satellites in that part of the sky. There's no, there are various ideas that obviously it was man-made, but there's enough ambiguity around the signal that that there's no easy explanation. There's no obvious explanation for that type of thing, an Earth generated radio signal. So they tried to point that telescope back to that part of the sky, and they never detected anything again. But it was a super strong signal.
Yeah, they've in the history of radio astronomy, they have the last I read was 8 known cases of anomalous signals coming from the Milky Way, and they've went off, and when they went back, they were gone.
Yeah.
And they were definitely not natural phenomena, but they were not repeatable. They didn't stay there. So,
well, there are so many interesting things that and I think that's what a lot of people don't realize, is that science, I love science, and I, and I'm a big, firm, science-minded person. But there are some things that we haven't quite explained yet. Science is, there are things at the cutting edge of our understanding. There are these weird flashes that happen on the surface of the moon that have been detected. And there's theories about why, that there are electrostatic charges because of the elements or the compounds that are in the lunar soil. And there's a lot of theories about it. Nobody's ever been able to definitively say, well, that's why you see flashes on the moon. That's just one little example, but there's things that have been seen and detected in orbit. We still don't understand all of the atmospheric phenomenon that happens, different types of lightning and different types of lights that happen in our atmosphere, especially as observed from space. Lightning observed from space is really neat, by the way. If viewers haven't watched, go watch some of the footage from the International Space Station. And I think they still have a live feed that you can watch at any time. It's really peaceful. And you usually have some really nice music in the background. But there's some really interesting observations of thunderstorms, lightning storms from above. Really crazy stuff. Really neat.
Oh, yeah. Some of the astronauts have commented that the lightning seems to go in a chain reaction. It starts in Minnesota and winds up in Georgia, and that's just their visual impression. But the Earth from the space station is a very dynamic place at nighttime. No question. Plus, they're confirming the existence of these things called sprites.
Yes.
Which are reverse direction lightning bolts going up rather than down.
Yes. That the lightning actually originates from the ground, or there's also streamers where they've got high-speed cameras that have detected the lightning coming up and down from the cloud at the same time. And then they meet, and that's when the bolt goes off.
Right.
Very, very interesting stuff. Yeah.
So,
well, we come to a little bit of a conclusion, I suppose. Is there anything else you'd like to talk about? It's been wonderful talking about this.
Yes, I want to tell your subscribers that you've probably read in the news about the Peregrine moonlander built in Pittsburgh. I'm not at liberty to describe a lot about the mission because I'm just a volunteer at their museum. But if you want to see it at the museum, come on over on the north side. It's between the Wendy's and McDonald's. But what I can tell you is that we were supposed to be on the moon months ago. Our ride to space, called the Vulcan Centaur rocket, had a problem a couple of months ago. One of the parts blew itself to bits. They're doing, I guess you'd call it engineering forensics on it. And now it's starting to look like the lander may not leave for the moon until November or December, because they have to take one of the fuel tanks in the upper stage and do a little beefing up. It was not strong enough to withstand the test that they did. Good thing that it happened on the ground, not in flight. So you won't miss this mission. It's going to be big on local news and national news. Returning to the moon for the first time in was it 51 years? Yeah.
Wow.
1972 was the last soft landing on the moon. Make sure to follow
that was Apollo 17.
Yeah, Apollo 17. Gene Cernan was the last person on there, and he says, we're coming back. God willing, we're coming back to the moon someday.
Let's just clarify for the viewers. So obviously Apollo 17 was a manned lunar mission. The Peregrine's not going to be a manned lunar mission, but it is going to land an object. A lander is going to land softly and not crash land into the moon. That's what you mean by soft landing. And people have been able to put personal payloads or scientific payloads, but there's also has been the opportunity to put Like for instance, there's a Japanese time capsule in a soda can. Is that right?
Yeah. There's a Japanese drink with the unfortunate name of Pocari Sweat. And they dumped the contents, and children of Japan wrote messages to the future. But again, I don't want to stray into their proprietary information. I would recommend going to the Astrobotic. It's called Astrobotic Technology website for all this
Yeah.
stuff. But I will tell you that this is more than just landing on the moon. This is the beginning of a new industry. So it's really quite historic. We've been on the moon before, but we've never started a brand new industry right before your eyes. And this lunar delivery service could be potentially very large. It's high risk, as you may know, Pat. There's been 3 attempts to soft land on the moon in the last 3 years. High-tech countries, Israel, India, and Japan, all those countries make their own airplanes, they make their own computers, and all 3 of their landers crashed. So
It's not a gimme.
their misfortune is our fortune, because from what I've been able to read online, we're finding out how they failed, and hopefully we pick those improvements on to the Peregrine lander.
This is a good lesson in life too. Failure is an opportunity for a learning experience.
Yeah.
I had the good fortune of being able to have you give me a tour of the Astrobotic display area, and I have to say, I would highly encourage anyone. It's only $10. You get to see something that's going to be on another world. I don't know how else to say that. It's beyond amazing, and you get to stand within yards of it. Obviously it's in a clean room, so it's sealed, but you get to look at that object in a very up close and personal way that you don't even get to look at, like the Wright Flyer in Washington, D.C. in the National Air and Space Museum. You get so close to it. And it's just that idea that also it's not cost prohibitive. If you want to put a payload on the next mission, it's not like unaffordable. You want to just okay, I wrote a novel and here it is on this microchip. I want to put, I want to take an SD drive, or SD card, micro SD card, and put it in there. You can do that. And it's not, I don't know what the price is going to be when that mission happens, but it's really not terribly expensive.
Well, what's going to happen is the price will go down as more missions are flown and more customers are signed up. But that's what's really neat. NASA does not and cannot put what I call human interest payloads on spacecraft. Human ashes, pop cans, you name it. They are under tax dollar control, and they've got to do science and engineering only. And they're glad to hire companies like Astrobotic and Intuitive Machines and some of the other companies to take stuff to the moon. But NASA is using these private companies to pre-stage some of their payloads and scientific experiments ahead of people returning to the moon.
Very cool. Very cool. I foresee, if will is there, an industry where, we return to some of the landing sites. There's an opportunity for there, like you said, you're trailblazing an entire industry. That's really what's going on.
Yeah. Oh, definitely.
All right. Well, it's been a great conversation. I'm so happy that we met. I'm so happy that you decided to come on the show, and I hope that our viewers enjoyed it as much as I did. Thanks, and maybe we'll do this again, and I'll see you at the observatory. Okay, Pat, and again, I hope to see you at some of our events, and best wishes to all your subscribers, and let's talk again sometime, and love to hear your comments on what we've talked about tonight. The possibilities are endless, really. Yeah. So thank you again. Good. Don't be shy. Put comments in the area below and start a conversation, and thanks again. We'll see you all. Take care, folks. Take care.